To turn on your calculator, simply press the on button. Off is a gold function. Press Shift, then AC to turn off your calculator. If you press Home, you can access the various sub-menus. You can scroll through the sub-menus using the arrows. If we want to scroll through the various lists of the sub-menus, we can use the arrows here. To select a particular sub-menu, scroll to your desired sub-menu, then press OK. To return back to the main menu, press Home. We can change the calculator's settings by pressing the Settings button. We can change the calc settings, we can change the system settings, we can reset our calculator, or we can take a look at the Getting Started option to get familiar with the calculator. Let's press back to return to the calculation screen. To reset your calculator, go to the Settings, scroll down to Reset, press OK. Typically, we would want to initialize all, which means we reset the calculator back to its default settings. If we scroll down to Initialize All and then press OK, we can then press OK once again to initialize all the settings. This would return the calculator back to its default settings. You will notice on your calculator there are various gold functions. These are shown above certain buttons. To access a gold function, we begin by pressing Shift, followed by a button which has a gold function above it. Notice when we press Shift, an S appears on the top bar of the screen. Let's take a look at an example. Suppose we want to access the gold function inverse sine. You will notice inverse sine is above the sine button. So, to access inverse sine, we begin by pressing Shift, followed by the sine button. We have the inverse sine function. We can use our calculator to store and recall values, and in this example, we have to work out 5a plus 2b subtract 3c when a is 4, b is -6, and c is 2. From our calculator, if we press variable, you will see that the variables a to f, x, y and z are currently all 0. That's because they have nothing stored in them. We want to replace the variable a with 4, the variable b with -6, and the variable c with 2. So, with the variable a, if I press execute, I want to edit variable a. I want to assign the value of 4 to variable a. Let's press execute again. You can see a has 4 stored into it. If we take a look at b, we want to store -6 into b, so if I press execute, then edit, we have b equals -6. We now want to store 2 into the variable c, so if I press execute, we want to edit and let c equal 2. Let's press AC to return to the calculation screen. Now if I press variable, you can indeed see A is 4, B is -6, and C is 2. Now we want to work out 5A plus 2B subtract 3C. So, if we wish to recall the variables, we can press Shift followed by the key in which the variable is associated with. So for example, you can see the variable A is attached to the 4 button, the variable B is attached to the 5 button, so on and so forth. So we have 5 and then A, so that's Shift and then 4, plus 2B, so that's Shift then 5, subtract 3C, so that's subtract 3 and then Shift and 6. 5A plus 2B subtract 3C with the values of A, B and C, you will find that to equal 2. Suppose we have the fraction 5 over 2. To input this, press the fraction button. We have 5 over 2. This is an improper fraction. If we press execute, our calculator begins by displaying for us the 5 over 2. We can convert this 5 over 2 to a decimal. If we press the format button, scroll down to decimal, then press execute, 5 over 2 is equal to 2.5. Now this 2.5 we can convert to a improper fraction. We press format, then scroll down to improper fraction, then press execute. We could also convert the result to a mixed fraction. If we scroll down to the mixed fraction option, then press execute, we see that 5 over 2 is the same as 2.5. Pi is a gold function. Press Shift, then 7, and if you press execute, we see that pi is displayed in exact form. If we press format, then scroll down to decimal and then press execute, we see the decimal equivalent, pi is equal to 3.141, etc. E is a gold function. Press Shift, then 8, then execute, we see that E is equal to 2.71, etc. Suppose we want to use the degrees mode. First of all, you will notice our calculator is in radians. We need to change this to degrees. If we press settings, then calc settings, scroll down to angle unit, press OK. We want to change to degree, so let's press OK, then AC to return to the calculation screen. A D appears on the top bar indicating we are in degrees. So let's see this in action. Suppose we want to work out the sine of 30 degrees. We have the sine of 30, which is equal to 1/2. Now let's suppose we want to use radians. Currently we are in degrees. We can change this to radians. If we press settings, calc settings, scroll down to angle unit, change the angle unit to radian by pressing OK, and if I press AC to return to the calculation screen, you will now see radians is in the top bar. So suppose we want to work out the inverse cosine of minus √3/2. in exact form? Well, we have the inverse cosine of minus root 3 over 2 you will find this to equal 5 pi over 6. We can use our calculator to work with powers and indices. Let's take a look at a couple of examples to illustrate this. Suppose we want to work out 6 squared. Now we can square a number using this function here. We have 6 squared. We find that to equal 36. Let's take a look at another example. Suppose we want to work out 3 to the power of 5. We can raise any number to the power of n using this button here. We have 3 to the power of 5, and if we press execute, you will find we get 243. Let's take a look at another example. Suppose we want to work out 2 to the power of negative 3. Well, we have 2 to the power of negative 3, and if we press execute, you will find we end up with 1/8. Let's take a look at another example. Suppose we want to work out 10 to the power of 3. Well, this is essentially the same as 1 multiplied by 10 to the power of 3. And we can work with powers of 10 using this button here. We have 1 times 10 to the power of 3, and if we press execute, we get 1000. Let's take a look at another example. Suppose we want to find the reciprocal of 5. The reciprocal function is a gold function. We have to press shift, then the nth power button. We have 5 to the negative 1 power. It turns out we get 1/5. The reason we have dedicated squared and reciprocal functions on our calculator is because they will be proved to be useful in other modes, such as vectors and matrix functions. We can find the square root and the nth root using our calculator. Let's begin by taking a look at square roots. Suppose we want to work out the square root of 4. The square root button is here. We have the square root of 4, and if we press execute, we see that is equal to 2. Let's suppose we want to work out the square root of 8. Press the square root button, then 8, press execute. We see in exact form the square root of 8 is equal to 2 root 2. Our calculator can also rationalize the denominator. Suppose we want to work out 8 plus square root 2 over 4 subtract the square root of 8. Begin by pressing the fraction button and input for the numerator 8 plus square root 2. Scroll down. For the denominator, we have 4 subtract the square root of 8, and if we press execute, you will see the result of this calculation is 9 plus 5 root 2 over 2. We can also work out the nth root. The nth root is a gold function and it's accessed by pressing Shift then the square root button. For example, if we were to work out the cube root of 27, press Shift then the square root button, we have the cube root, so we press the 3 and then the 27 goes under the cube root, press execute. The result of the cube root of 27 is 3. Now, for another example, suppose we want to work out the fourth root of 625. Press Shift and the square root button. We have the fourth root of 625. Press execute. We end up with 5. We can use our calculator to perform calculations involving logarithms. Let's take a look at a couple of examples to illustrate this. We begin with log base 2 of 3. Now, log base n button is here. We have log base 2 of 3, and if we press execute, you can see we end up with 1.58, etc. Let's take a look at another example. Suppose we want to work out log base 10 of 100. We have log base 10 of 100. It turns out we get 2. There is another way of performing this calculation. We could use the log feature instead. Log is a gold function. Press Shift, then the squared button. We have log of 100, which, if we work this out, indeed, we get 2. Let's take a look at another example. Suppose we want to work out log base e of 5. We have log with a base of e, so that's Shift and 8. Log base e of 5. It turns out that's 1.609, etc. We could also use the natural log instead of the log base n feature. Of course, log base e of 5 is the same as natural log of 5. The natural log is a gold function. Press Shift, then the log base n button. The natural log of 5, indeed, we do get 1.609, etc. We can work out factorials using our calculator. In this example, we have to work out 6 factorial. Begin by pressing 6. Now, to access the factorial function, go to the catalogue, scroll down to probability, and then scroll down to factorial. 6 factorial is equal to 720. We can use our calculator to work out the absolute value. Suppose we want to work out the absolute value of -5. If we go to the catalogue and then scroll down to numeric calc, what we want is the absolute value, and that's shown by this symbol here. If we type in -5, the absolute value of -5 is equal to 5. We can use our calculator to calculate ratios. From the main menu, scroll down to the ratio submenu and then press execute. Now in this example, we have to calculate x in the ratio 1 to 2 equals x to 10. So the type we have here is the first type, a to b equals x to 10. We have a, which is 1, b, which is 2, and d, which is 10. If we press execute, we can input those in. We have 1 to 2 equals x to 10. And if we press execute, you will see x is equal to 5. We can use our calculator to work with percentages. In this example, we have to work out 5% of 120. Begin by pressing 5. Now we want 5%. So if we go to the catalogue and then scroll down to probability, we can select the percentage function. We have 5% and then we want to work out 5% of 120. So if I multiply 5% by 120, what you can see is we end up with 6. We can use our calculator to create a table of values from which we can sketch graphs. Now in this example, we have to sketch the functions f of x equals sin x and g of x equals 2 cos x in the domain 0 to 2 pi. The first thing we need to do from the main menu is go to the table sub-menu. We then press tools. We need to define f of x. We also need to define g of x. So if we define f of x is equal to sin x. Press execute. We also need to define g of x. Following the same steps, g of x is equal to 2 multiplied by the cosine of x. We now need to input our range and the step. If we press tools and go to table range, we are starting at x equals 0. We end at 2 pi. Our step is a half pi, from 0 to a half pi, and then from a half pi to pi, and then from pi to 3 pi over 2, and then from 3 pi over 2 to 2 pi. That is a step of a half pi. If we execute this, you can see our calculator creates a table of values, and that is shown here. We can then use the QR feature on our calculator to visualize the graph and then sketch it. We can use our calculator to use the combination function. Suppose we want to work out 5 choose 3. Begin by pressing 5. To access the combination function, press catalogue, scroll to probability, and then scroll to combination. We have 5 choose and then 3. And if we press execute, you will find this to equal 10. We can use our calculator to work out the gradient of a tangent to a curve at a particular point. Let's take a look at an example to illustrate this. We have to find the gradient of the tangent to the curve y equals x cubed subtract 4x at the point 3, 10. First thing we need to do with our curve y equals x cubed subtract 4x is differentiate it. And if we differentiate, we end up with dy over dx equals 3x squared subtract 4. Now, with the point x equals 3, we can substitute this into dy over dx. We have 3 multiplied by 3 squared subtract 4, and that's equal to 23. We can verify this with our calculator. If we go to the catalogue, then functional analysis, we are required to work out a derivative at a particular point. We want to differentiate our function of y. So we key in x cubed subtract 4x. We are differentiating x cubed subtract 4x, and then we are working out the value of dy over dx at the point x equals 3. And so if we work this out, we get a value of 23. We can use our calculator to work out integrals. In this example, we have to work out the integral of x to the negative 3 over 2 plus 6x to the half with respect to x from x equals 1 to x equals 4. From the calculation screen, if we go to the catalogue, then functional analysis, we will be integrating, so we require the integration function. Key in your expression. In this case, we have x to the negative 3 over 2 plus 6x to the 1/2 we are going from x equals 1 to x equals 4. You will find our calculator computes this. Our calculator ends up with a result of 29. We can use our calculator to work out summations. Now in this example, we have to work out the sum from x equals 4 to x equals 7 of 3x subtract 2. From the calculation screen, if we press catalogue, then select the functional analysis, we want a summation, so scroll down to summation, type in the expression. In this case, we have 3x subtract 2. We are going from x equals 4 to x equals 7. You will find the sum to equal 58. We can solve certain types of equations using our calculator. In this example, we have to solve 4 times the natural log of x equals x, where x doesn't equal 0. From the main menu, go to the equation sub-menu and then press execute. If we scroll down to solver and then press execute, we need to input in our equation. Now you will notice we have a dedicated X button which we can use to input our equation. So we have 4 multiplied by the natural log of x. Now we need to type in the equals. Equals is a gold function. Press shift and open bracket and then type in x again. We have our equation, 4 times the natural log of x equals x. Then press execute. We need to enter in our initial value. We can choose any initial value. For example, we can choose the initial value 0.5. If we execute this, our value of x is 1.429, etc. We can use our calculator to work out the product of prime factors. For example, we can factorize 120 into its product of prime factors using our calculator. If we key in 120, then press execute, we can then press format and scroll down to prime factor. You will find 120 is equal to 2 cubed times 3 times 5. We can use our calculator to work with sexagesimal, in other words, base 60. And in this example, we have to work out 2 degrees, 20 minutes, 30 seconds plus 9 minutes, 30 seconds. And we have to convert the result to its decimal equivalent. So we will be adding together 2 degrees, 20 minutes, 30 seconds to 9 minutes, 30 seconds. Now with the 9 minutes and 30 seconds, we have 0 degrees, but we still have to input that in. So we have 2 degrees, 20 minutes, 30 seconds plus 0 degrees, 9 minutes, 30 seconds. And of course, 0 degrees, 9 minutes, 30 seconds is just the same as 9 minutes and 30 seconds. So how do we go about inputting this into our calculator? Well, we have to use the sexagesimal feature. Sexagesimal is a goal function, and it's accessed by pressing Shift then the plus button. We have 2 degrees, 20 minutes, 30 seconds plus 0 degrees, 9 minutes, 30 seconds. And if we press execute, we end up with 2 degrees, 30 minutes, 0 seconds. And to convert this to its decimal equivalent, press format, go to decimal, press execute. The decimal equivalent is 2.5. We can use our calculator to work with hyperbolic trigonometry functions. For example, if we are required to work out hyperbolic cosine of 2, from the calculation screen, press catalog, scroll down to hyperbolic/trig, then press OK. Scroll down to hyperbolic cosine and then press execute. We have hyperbolic cosine of 2, which is equal to 3.76, etc. Let's take a look at another example. Suppose we want to work out the inverse hyperbolic tangent of 0.1. Well, from the calculation screen, press catalog, scroll down to hyperbolic/trig, press OK. Scroll down to inverse hyperbolic tangent, then press execute. We have the inverse hyperbolic tangent of 0.1, which is equal to 0.1003, etc. We can use our calculator to solve simultaneous equations with 2 unknowns. In this example, we have to solve these simultaneous equations: 2x subtract 3y equals 6, x plus y equals 3. From the main menu, go to the equation sub-menu. We have a simultaneous equation with 2 unknowns. Enter in the coefficients. We have 2x subtract 3y. This is equal to 6. We also have 1x plus 1y equals 3. If we press execute, you can see x is 3 and y is 0. We have x is 3, y is 0. We can use our calculator to solve simultaneous equations with 3 unknowns. In this example, we have to solve these simultaneous equations. X plus y subtract z equals 4, x subtract 2y plus 3z equals negative 6, 2x plus 3y plus z equals 7. Now from the main menu, scroll to the equation sub-menu. We have a simultaneous equation with 3 unknowns. We have 1x plus 1y subtract 1z equals 4. We have 1x subtract 2y plus 3z equals negative 6. We have 2x plus 3y plus 1z equals 7. If we press execute, our calculator tells us x is 1, y is 2, and z is negative 1. And that's what we see here. We have a solution, x equals 1, y equals 2, and z equals negative 1. We can use our calculator to solve simultaneous equations with 4 unknowns. In this example, we have to solve these simultaneous equations. 2x subtract 3y plus 5z plus t equals negative 41. 7x plus 2y subtract z equals negative 28. Negative x plus 2y subtract 7z subtract 2t equals 46. And 3x plus 7y subtract 6z plus t equals 31. From the main menu, scroll down to the equation sub-menu. We have a simultaneous equation with 4 unknowns. For the first equation, we have 2x subtract 3y plus 5z plus 1t equals negative 41. For the second equation, we have 7x plus 2y subtract 1z plus 0t equals negative 28. For the third equation, we have negative 1x plus 2y subtract 7z subtract 2t equals 46. And for the fourth equation, we have 3x plus 7y subtract 6z plus 1t equals 31. Our calculator tells us x is negative 5, y is 0, z is negative 7, and t is 4. So we have solutions x equals negative 5, y equals 0, z equals negative 7, and t equals 4. We can use our calculator to solve quadratic equations and use our calculator to find turning points of graphs. So in this example, we have to solve 2x squared subtract x subtract 3 equals 0, and hence find the coordinates of the turning point of the graph y equals 2x squared subtract x subtract 3. From the main menu, scroll to equation. We have a polynomial, we have a quadratic, we have 2x squared subtract 1x subtract 3 equals 0. Our calculator will tell us x is equal to 3 over 2 and negative 1. as we see here. If we press execute again, we see that the minimum x coordinate is 1/4 and the minimum y coordinate is -25/8, as we see here. So our turning point has coordinates 1/4 and -25/8. We can use our calculator to solve cubic equations and also use our calculator to find local maximum and minimum points of cubic functions. Now in this example, we have to solve -3x cubed plus 7x squared plus 2x negative 8 equals 0, and hence find the coordinates of the local maximum and minimum points of the graph y equals -3x cubed plus 7x squared plus 2x subtract 8. From the main menu, go to the equation sub-menu, then polynomial. We have a cubic, we have -3x cubed plus 7x squared plus 2x subtract 8 equals 0. Our calculator tells us x is equal to -1, x is equal to 2, and x is equal to 4/3. We have x equals -1, x equals 2, and x equals 4/3. If we press execute again, our calculator tells us the maximum point is 7 plus root 67/9, and if I convert this to a decimal, we have 1.687, etc. and the y coordinate is 0.892, etc. of this local maximum. If I press execute once again, we find that the local minimum has an x coordinate of 7 subtract root 67/9, which as a decimal is -0.131, etc. and the y coordinate of the local minimum point is -8.13, etc. and that's summarized here. We can use our calculator to solve quartic equations. For example, suppose we want to solve x to the 4 subtract 9x cubed plus 22x squared plus 28x subtract 120 equals 0. From the main menu, go to the equation sub-menu. We have a polynomial of degree 4. We have 1x to the 4 subtract 9x cubed plus 22x squared plus 28x subtract 120. Our calculator will tell us that x is 3, x is -2, x is 4 plus 2i, and 4 subtract 2i. And that's what we see here. We have x equals 3, x equals -2, x equals 4 plus 2i, x equals 4 subtract 2i. We can use our calculator to solve inequalities. From the main menu, scroll down to the inequality sub-menu, and our calculator allows us to solve quadratic, cubic, and quartic inequalities. Let's take a look at an example. Suppose we want to solve the quadratic inequality x squared subtract x subtract 6 greater than 0. Selecting the first option for quadratic inequalities, we now need to match up the type. We have something greater than 0, so that's its first type here. So we have 1x squared subtract 1x subtract 6 being greater than 0. Our calculator displays for us the solutions. X is less than -2 and x is greater than 3. Let's take a look at another example where we have to solve this time the cubic x cubed subtract 5x squared plus 6x being less than or equal to 0. We select the cubic inequality solver. We now need to match up the type we have. We have something less than or equal to 0. So that's this here. We have 1x cubed subtract 5x squared plus 6x plus 0 is less than or equal to 0. Our calculator tells us x is less than or equal to 0 and x is in between 2 and 3. We can use our calculator to calculate summary statistics for data. In this example, we have to calculate the summary statistics for this particular set of data. From the main menu, go to the Statistics sub-menu and press OK. We have one variable statistics because we are only concerned with the score. If we press Execute, you will notice, for now, there is no frequency. We have to turn on the frequency. If we press Tools, scroll to Frequency, and press OK, we want to turn the frequency on. So now if we go back to where we input our data, we can now enter in the frequency. For a score of 4, we have a frequency of 1. For a score of 7, we have a frequency of 4. For a score of 2, we have a frequency of 6. For a score of 8, we have a frequency of 4. For a score of 2, we have a frequency of 2. For a score of 9, we have a frequency of 3. We have now inputted all the data. If I press Execute once again, the calculator gives us two options. We can return to a calculation screen, or we can calculate the one variable results. Calculating the one variable results, press Execute. You will see that the statistics summary are displayed on your calculator screen. So, for the 20 pieces of data, and the reason I know I have 20 pieces of data, n is 20, we see the following statistics summary. The mean is 5.35, the median is 7, the sum of the x's is 107, the sum of the x squareds is 743. The variance, if we use sigma squared, that's 8.5275, and if we use s squared instead, the variance is 8.976, etc. For the standard deviation, if we use sigma, we end up with 2.920, etc. And if we use sx, the standard deviation is 2.99, etc. The maximum value is 9, the minimum value is 2, the lower quartile is 2, the upper quartile is 8. We can use our calculator to calculate the product moment correlation coefficient. Let's take a look at how to do this using an example. In this example, we have to calculate the product moment correlation coefficient for the following data. From the main menu, if we scroll to the Statistics sub-menu, we have two variables because we have x and y. Press Execute. We can enter in our x and y data. we have 4, 13. Then we have 4, 12. We have 8 and 19. We have 7 and 23. We have 12 and 33. Then we have 12 and 37. Then we have 3 and 10. Now that we have inputted all of the data, press execute. What we want is the regression results. We want y equals ax plus b. The value of r we require is 0.974, etc. The product moment correlation coefficient then is 0.974, etc. We can use our calculator to work with binomial distribution. In this example, we are given that x is binomially distributed with parameters 20 and 0.4, and with this we have to calculate the probability that x is equal to 3. From the main menu, go to the distribution sub-menu. What we have, because we are calculating x equals something, we need a binomial PD. If we scroll down to variable, x is equal to 3, n, that's equal to 20, p, that's equal to 0.4, and if we execute this calculation, we see that the probability that x is equal to 3 is 0.0123, etc. We can use our calculator to work with binomial distributions. Now in this example we are given that x is binomially distributed with parameters 20 and 0.4, and with this we have to calculate the probability that x is less than or equal to 7. From the main menu, go to the distribution sub-menu, scroll down to binomial CD, scroll down to variable, x is 7, n is 20, p is 0.4, and if we execute this, you will find that the probability that x is less than or equal to 7 is 0.415, etc. We can use our calculator to work out normal distributions. Now in this example, we are given that x is normally distributed with parameters 30 and 4 squared, and with this we have to find the probability that x is less than 33. From the main menu, if we go to the distribution sub-menu, we have to go to normal CD, our lower limit would be something really small. For example, negative 1 million is what I normally choose. Our upper limit would be the 33. Mu will be 30, and sigma is equal to 4. If we execute this calculation, we see that the probability that x is less than 33 is 0.773, etc. We can use our calculator to work with inverse normals. Now in this example we are given that x is normally distributed with parameters 20 and 3 squared, and with this we have to find the value of x such that the probability that x is less than x is 0.75. If we draw a diagram to illustrate this, we have the following. We have to calculate the value of x for which the probability of x being less than x is 0.75. So this yellow shaded area corresponds to the 0.75, and we've got the mean, which is 20. From our main menu, if we go to the distribution sub-menu, scroll down to inverse normal, the area is the probability of 0.75, mu is 20, sigma is 3. If we execute this, you will find x to equal 22.023, etc. We can use our calculator to work out Poisson distributions. In this example, we are given that x has a Poisson distribution with a parameter of 5, and with this we have to find the probability that x equals 2. From the main menu, go to the distribution sub-menu, scroll down to Poisson PD, scroll down to variable, x is 2, lambda is 5, and if we execute this, you will see that the probability that x equals 2 is 0.084, etc. We can use our calculator to work with Poisson distributions. In this example, we are given that x follows a Poisson distribution with a parameter of 5, and with this we have to find the probability that x is less than or equal to 3. From the main menu, go to the distribution sub-menu, scroll down to Poisson CD, scroll down to variable, x is 3, lambda is 5, and if we execute this, you will find the probability that x is less than or equal to 3 is equal to 0.265, etc. We can use our calculator to convert units. In this particular example, we have to convert 5 kilometers per hour to meters per second. Now, if we go to the catalog and then scroll down to unit conversions, we can convert various units. We can convert lengths, areas, volumes, masses, velocities, pressures, energy, power, and temperature. Now in our case, we want to convert velocities. We've got units of velocities which we are required to convert. So let's press execute. We want to convert kilometers per hour to meters per second. So here we can see we are converting kilometers per hour to meters per second. Now if I scroll the cursor right, I need to make sure that we are converting the amount correctly. In this case we have 5 kilometers per hour, which we need to convert to meters per second. And if I convert that to meters per second, you can see 5 kilometers per hour is equal to 25/18 meters per second. We can use our calculator to work with iterative formulas. In this question, we have to show that x squared subtract x subtract 5 rearranges to x equals the square root of 5 plus x, and hence use the formula xn plus 1 equals the square root of 5 plus xn, with x naught equaling 1, to find an approximate solution to the equation x squared subtract x subtract 5 equals 0. Now we begin with the x squared subtract x subtract 5 equals 0. Rearranging, we have x squared equals x plus 5, and if we square root, you will find that x equals the square root of 5 plus x. So now we are given that x0 equals 1. So we type in 1 and then execute. Currently, in the answer function, 1 is stored into it. So we can type in the right hand side of our iterative formula, replacing xn with answer. We have the square root of 5 plus xn, which we're going to use the answer function for. So with this we can find out what x1 is. It stores the previous value into the calculation. So if we work out what x1 is, that's the square root of 5 plus x0. So working this out, we get the square root of 6, which as a decimal you will find to be 2.449, etc. So now, to find out what x2 is, well, that's going to equal the square root of 5 plus x1. So storing our previous value in for x1, we have 5 plus the 2.449, etc. And if I press execute, we get 2.7, etc. Then for x3, same idea. That's the square root of 5 plus x2. So we have the square root of 5 plus 2.72, etc. And working this out, we get 2.78, etc. x4, that's equal to the square root of 5 plus x3. So we have the square root of 5 plus 2.78, etc. And working this out, we get 2.789, etc. x5, that's the square root of 5 plus x4. So we have the square root of 5 plus 2.789, etc. And if I press execute, you will find we get 2.79, etc. Now we can continue. If I continuously press execute, at one point the decimals stop changing. And what you can see is it stops changing when we have the 2.7912887847. So this is our solution. Now let's just double check we indeed have the right answer. Let's substitute in this value of x into the left hand side to see if we get 0. So we have answer squared, subtract answer, subtract 5. We get a value which is really small. So this is a good iterative formula to use because this value is very close to 0. We have some sort of an error given in our calculation. However, this is a reasonable approximate solution. We can use our calculator to find the real and imaginary part of complex numbers. For example, we have to find the real and imaginary part of 6 plus 9i. If we go to the complex sub-menu, then to the catalogue, go to the complex section, scroll down to real part. We want the real part of 6 plus 9i. If we work this out, we get 6. If we want to work out the imaginary part, go back to the catalogue, then the complex option, scroll down to imaginary part, we want the imaginary part of 6 plus 9i. We get 9. So the real part is 6, the imaginary part is 9. We can use our calculator to find complex conjugates. For example, we can find the complex conjugate of 1/2 subtract 5/6i. Now if z is equal to 1/2 subtract 5/6i, we can find the complex conjugate using our calculator. From the main menu, if we scroll to the complex sub menu, then go to catalog, then the complex option, scroll down to conjugate. We want the complex conjugate of 1/2 subtract 5/6i. It turns out the complex conjugate is equal to 1/2 plus 5/6i. We can use our calculator to perform complex arithmetic. From the main menu, go to the complex sub menu. Notice we have an I on the top bar indicating we are in Cartesian format. Now let's take a look at a couple of examples. For the first example, we have to calculate 3 plus 2i subtract 5 subtract 4i. Now I is a gold function. It's accessed by pressing Shift, then 9. We have 3 plus 2i subtract 5 subtract 4i. And if we work this out, we get -2 plus 6i. Let's take a look at another example. Suppose we want to multiply 2 plus I by 6 subtract 4i. We have 2 plus I being multiplied by 6 subtract 4i. And if we work out what this is equal to, we get 16 subtract 2i. Let's take a look at another example. Suppose we want to work out 7 plus 4i divided by 1 subtract 2i. We have 7 plus 4i divided by 1 subtract 2i. It turns out we get -1/5 plus 18/5i. We can convert Cartesian to polar form on our calculator. For example, suppose we want to write the complex number 1 subtract square root 3i in the form re to the I theta, where theta is in between -pi and pi. This can be performed using our calculator. From the main menu, if we scroll to the complex sub menu, you will first of all notice we have an I on the top bar. We want to change this. If we go to the settings, then the calc settings, if we scroll to the complex result settings, we want to display our answer in the form r theta. So once this has been selected, let's return to the calculation screen. You will notice now our calculator will display the answers for us in complex mode re to the I theta. Notice as well we are in radians as our argument is in radians. So if I type in the complex number 1 subtract square root 3i, if I press execute, our calculator tells us that r is 2 and theta is -1/3 pi. Therefore, z, our complex number, is equal to 2e to the minus pi over 3I. We can use our calculator to convert from polar form to Cartesian form. Now in this example we have to write 2e to the pi over 4i in the form a plus bi, where a and b are real numbers. From the menu, go to the complex sub-menu. Now you will notice we have an I, indicating our final answer will be in Cartesian format. Now, because we are in polar format for now, we need to input the 2e to the pi over 4i in polar format. So we have 2, and then if I go to the catalogue, then complex, scroll down to where we have the angle, we have 2 as the mod, and the argument is pi over 4. And if I press execute, you will see that our complex number is square root 2 plus square root 2i. We can use our calculator to calculate unit vectors. In this example, we're given the vector a, 420, and we have to calculate the unit vector of a. From the main menu, let's scroll to the vector sub-menu. We need to define vector a. To do this, press Tools, then vector a. We need to change the dimensions to 3 dimensions. We have I, j, and k. And if we confirm this, we can key in the I component of 4, the j component of 2, the k component of 0. And if we press execute, vector a is now stored into the calculator. We want to calculate a unit vector. If we go to the catalogue, then vector, then vector calc, what we want is a unit vector. We want the unit vector of a, so then go to the catalogue again, go to vector, we want vector a. You will find then the unit vector of a is 0.89 etc. I plus 0.44 etc. j plus 0 k. We can use our calculator to calculate the magnitude of a vector. Here we have vector a, 420, and we have to calculate the magnitude of vector a. From the main menu, if we go to the vector sub-menu, we begin by defining vector a. It has 3 dimensions. Vector a is 4, 2, 0. Vector a is now stored into the calculator. We want to calculate the magnitude of vector a, which means we need the absolute value feature on our calculator. So if we go to the catalogue, then scroll to numeric calc, we want the absolute value of vector a. So if we go back to the catalogue, then select vector, we want vector a. Here we have the absolute value of vector a, which is equal to 4.472, etc. We can use our calculator for vector arithmetic. Here we have vector a equal to 420 and vector b equal to 8, negative 42. We have to calculate 2a subtract 3b. From the main menu, if we go to the vector sub-menu, we need to define vectors a and b. So if we press Tools, we can define vector a. Vector a has 3 dimensions. It's equal to 4, 2, 0. We can define vector b if we press Tools, then go to vector b. Vector b has 3 dimensions. It's equal to 8, negative 4, 2. Vectors a and b are now defined. We want to work out 2a subtract 3b. So we have 2 And then we want to load up vector A, so press catalog, vector, then we want vector A, subtract 3 times vector B, so we go to the catalog, vector B, 2 times vector A, subtract 3 times vector B, that's equal to negative 16, 16, negative 6. We can use our calculator to calculate the scalar dot product between two vectors. Here we have vector A, 420, and vector B, 8, negative 42. We have to calculate the scalar dot product between vector A and vector B. From the main menu, if we go to the vector sub menu, we want to define vector A. Vector A has 3 dimensions. It's equal to 4, 2, 0. We also want to define vector B. If we go to tools, we can define vector B. Vector B has 3 dimensions. It's equal to 8, negative 4, 2. Vectors A and B are stored in the calculator. We want the scalar dot product, so if we go to catalog, then vector, vector calc, we want the dot product between vectors A and B. So we have vector A dot with vector B, and it turns out we get 24. We can use our calculator to calculate the cross product between two vectors. Here we have vector A, 420, and vector B, 8, negative 42. We have to calculate the cross product between vector A and vector B. From the main menu, if we go to the vector sub menu, we need to define vectors A and B. So press tools, we want to define vector A. Vector A has 3 dimensions. It's equal to 4, 2, 0. We also want to define vector B, so go to tools, vector B. The dimensions of vector B will be 3. It's equal to 8, negative 4, 2. Vectors A and B are stored in the calculator. We want the cross product. So if we go to catalog, then vector calc, we want the cross product. So we have vector A, which we need to load up, cross with vector B. So if we work out the cross product is equal to 4, negative 8, negative 32. We can use our calculator to calculate the angle between two vectors. In this example, we have vector A, 420, and vector B, 8 minus 42. We have to calculate the angle, theta radians, between vector A and vector B. From the main menu, go to the vector sub menu. We want to define vectors A and B. Press tools. We will say that vector A has 3 dimensions. It's equal to 4, 2, 0. We also need to define vector b, so press tools. We will define vector b. Vector b has 3 dimensions. It's equal to 8, -4, 2. We want to calculate the angle between these vectors, so if we go to the catalogue, then vector calc, we want the angle between these vectors. So we want the angle between vector A, so we go to vector from the catalogue menu. Then we want a comma. Comma is a gold function. Press shift, then close bracket. Then we want vector B. So go to catalogue, vector B, close bracket. The angle between vectors A and vector B is 0.945. We can use our calculator to work out arithmetic involving matrices. Now here we have the matrix A, 4 minus 1, 7, 2, 4 minus 8, 0, 5 minus 7, and we have the matrix B, 8, 1, 1, minus 4, 5 minus 3, 2, 0, 6. We have to calculate 2A minus 3B. Well, the first thing we need to do is go to the matrix sub-menu. We need to define matrix A and B. So if we click Tools, we will define matrix A. Matrix A has 3 rows. Matrix B has 3 columns. We have 4 minus 1, 7, 2, 4, minus 8, 0, 5, minus 7. Let's now define matrix B. So if we go to Tools, we will define matrix B. Matrix B has 3 rows and 3 columns. We have 8, 1, 1, minus 4, 5, minus 3, 2, 0, 6. So, matrix A and B are stored into the calculator. So we have 2 multiplied by the matrix A. So to load up matrix A, we press catalogue, matrix, then scroll down to matrix A. Then we subtract 3 multiplied by the matrix B. So to load up matrix B, press catalogue, matrix, and scroll down to matrix B. And if we work this out, you will find we get minus 16, 5, 11, 16, minus 7, minus 7, minus 6, 10, minus 32. We can use our calculator to calculate determinants of matrices. Here we have the matrix A, 4 minus 1, 7, 2, 4 minus 8, 0, 5 minus 7. We have to calculate the determinant of A. Our first step is to first of all define matrix A. If we go to the matrix sub-menu, then go to Tools, then matrix A has 3 rows and 3 columns. It's equal to 4, minus 1, 7, 2, 4, minus 8, 0, 5, minus 7. A is now stored into the calculator. If we now go to the catalogue, then matrix calc, we want the determinant, so scroll down to determinant. We want the determinant of matrix A, so we have the determinant of matrix A. Our calculator calculates the determinant to be 104. We can transpose a matrix using our calculator. Here we have matrix A, 4 minus 1, 7, 2, 4 minus 8, 0, 5 minus 7. We have to calculate the transposition of A. From the main menu, if we go to the matrix sub-menu, we need to define matrix A. So if we define matrix A, the number of rows we have is 3. The number of columns we have is 3. So for matrix A we have 4 minus 1, 7, 2, 4, minus 8, 0, 5, minus 7. So now that matrix A is stored into the calculator, we want to calculate the transposition of matrix A. So if we go to the catalogue, then matrix calc, scroll down to transposition, we want the transposition of A. So if we go back to the catalogue, then matrix, scroll down to matrix A, the transposition of matrix A is 420 minus 145, 7 minus 8 minus 7. We can use our calculator to calculate the inverse of a matrix. Now here we have the matrix A, 4 minus 1, 7, 2, 4 minus 8, 0, 5 minus 7, and we have to calculate A inverse. Now we need to input the matrix A into our calculator. So if we go to the matrix sub-menu, we need to define matrix A, so press tools. And if we define matrix A has 3 rows. Matrix A has 3 columns. Let's confirm this. So now we have matrix A, we've got 4 minus 1, 7, 2, 4, minus 8, 0, 5, minus 7. And if we press execute, then matrix A is stored into the calculator. So now we want to calculate the inverse of A. So if we load up matrix A, so we click catalogue, then matrix, scroll down to matrix A. We want matrix A inversed, so then we click catalogue, then matrix calc. We want the inverse matrix, and if we calculate this, you see here we have our inverse matrix. We have 3 over 26, 7 over 26, minus 5 over 26, 7 over 52, minus 7 over 26, 23 over 52, 5 over 52, minus 5 over 26, 9 over 52. We can use our calculator to work out the product of two matrices. Here we have matrix A 4 minus 1 7, 2 4 minus 8 0 5 minus 7, and matrix B 8 1 1 minus 4 5 minus 3 2 0 6. We have to calculate matrix A multiplied by matrix B. If we go to the matrix sub menu, we need to define matrix A and B. So if we go to tools, we will define matrix A. The number of rows it has is 3. The number of columns it has is 3. So we have 4 minus 1, 7, 2, 4, minus 8, 0, 5, minus 7, we now need to define matrix B. So if we go to tools, scroll down for matrix B, the number of rows it has is 3. The number of columns it has is 3. So we have 8, 1, 1, minus 4, 5, minus 3, 2, 0, and 6. So now matrix A and B are stored into the calculator. We can load up matrix A. Then matrix. Then scroll down to matrix A. And then press OK. Then we will multiply matrix B. So then we go to catalog. Then go to the matrix. Then matrix B. Then press OK. And if we execute this, our calculator tells us that matrix A times matrix B is 50 minus 149 minus 16, 22, minus 58, minus 34, 25, minus 57. We can use our calculator to square matrices. For example, we are given the matrix A 4 minus 1 7, 2 4 minus 8, 0 5 minus 7, and we have to find A squared. Now from the main menu, go to the matrix sub-menu. We need to define matrix A, so click Tools, click OK on matrix A. Matrix A has 3 rows, matrix A has 3 columns. Let's confirm this. We have matrix A which is equal to 4, minus 1, 7, 2, 4, minus 8, 0, 5, minus 7. Matrix A is now stored into the calculator, and we want to work out A squared. So if we click on the catalogue option, then matrix, we have matrix A, which we want to deal with, and then what we want to do is square it. So once we click catalogue, select OK for matrix, matrix calc, we want to work out matrix squared. And we could work out the matrix cubed as well if we needed to. Here we are just working out matrix squared, and if we work this out, our calculator will tell us that the matrix A squared is equal to 14, 27 minus 13, 16 minus 26, 38, 10 minus 15, 9.